Hey everybody, we made it to the end of Unit 4. Here is our last lesson, solving two-step inequalities. U4.C6.L8. Here's Mrs. Benoit.
Hi. Okay, so our target for this lesson is that you will be able to say, I can solve two-step inequalities with any operation. Now we know you can solve two-step equations, so we're just going to do the same thing, but with inequalities. And by the end of this video, you should be able to do these two problems here, and we'll see those again at the end. Okay, so let's look at a couple of examples. This first one I have is 3 times x plus 4 is greater than or equal to 16. So just like with two-step equations, we're going to start by drawing our wall. And then we're going to undo the addition or subtraction first. In this one we have plus 4. So to undo that, we're going to subtract 4 from both sides. We're left with 3x. We have our greater than or equal to symbol. And then 16 minus 4 is 12. The second step, remember, would be to undo the multiplication or division. And in this case, we have 3 times x, so we're going to divide both sides by 3. 3 divided by 3 is 1x, is greater than or equal to, and 12 divided by 3 is 4. So this is our possible solution set for our two-step inequality. X is greater than or equal to 4. Now we're going to get ready to draw our graph. Remember, in our solution set, that number that's there, that goes in the middle of our number line, so we have 4. And we're going to go 1 or 2 to the right of 4, and 1 or 2 to the left of 4. And from the last lesson and previous lessons, the symbol tells us what kind of circle to put on our number line. In this case, we have greater than or equal to, so it's going to be a closed circle on our target number, which is 4. And at this point, I ask you to read it again. Read it to yourself again. X is greater than or equal to 4. So we want x to be greater, so we're going to shade to the right. Now we're going to have you check this a little bit differently here, and we're going to have you test one that falls in your shading and one that doesn't, to make sure that it's a true statement with one that does and a not true statement with one that doesn't. So we have shaded in here to the right of 4, so let's try 5. If we put 5 in for x, is 5 greater than or equal to 4? Yes. So we know that's okay. Now let's test one that we didn't shade on the other side of 4. We'll go ahead and put 3 in. Would 3 be greater than or equal to 4? No, that's not true. So our graph is right. Our solution set is good. That's one kind of problem that you will see. Here's another. And the last unit talked about multiplication and division with negatives. So we're going to look at one of those here, okay? But we're going to start this the same way as the last one by drawing our wall. We have the opposite of x divided by 2 minus 5 is less than negative 8. And after drawing our wall, the first step is to undo the addition and subtraction. So we're going to add 5 to both sides. Okay. Minus 5 plus 5 makes 0, so we have the opposite of x over 2. Bring down your inequality symbol. And negative 8 plus 5, going back to Unit 1 integers, subtract. And keep the sign of the larger absolute value, so that's negative 3. Okay, second step, undo multiplication or division. This is division, so we're going to do the opposite, multiply. And we're going to multiply both sides by the reciprocal or the flip. Dividing by 2 would be times 2 over 1. And this is a negative 2 over 1 because of that negative in front of our division. And what we do on the right, or on the left, excuse me, we have to do on the right. These cancel out and we're left with a positive x. What happens to our inequality? Do you remember? It reverses because There was a negative with the variable. Now that's going to the other side, so we have to reverse that inequality. X is greater than 6 is our solution set. So let's see what that would look like on a graph. Our target number 6 goes in the middle. We have 2 higher, 1 or 2 higher, depending, and 1 or 2 lower. This time we're going to have an open circle on our target number because it's just greater than. And being greater than 6 means to shade to the right. 7, 8, 9, and so on. And let's do our test like last time. So let's test one that's shaded and see if it works. Oops, let me get a better marker here. 7. Is 7 greater than 6? Yes, that makes sense. Now let's test one that wasn't shaded to see if that also would then be an untrue statement. 5. Is 5 greater than 6? No, that's not true. So we know we shaded the right way? Okay, so with just those 2 examples, we are hoping that you will be able to hit that target that we talked about in the beginning, solve 2-step inequalities with any operation. We'd like you to try these 2 problems here, and don't forget, when a negative is involved, something happens to your inequality symbol.